Hello, everybody. Welcome back to Mathlete's Corner. We're 10 questions into the test. The stress is gone, and we're going to keep it going with problems 11 through 15. So, for the first problem in this video, problem 11. The coordinates of triangle ABC are 5, 7, 11, 7, and 3y, with y more than 7. The area of triangle ABC is 12. What is the value of y? So, this problem is just straight geometry formulas. We know the base of the triangle AB has a length of 6 because this one is 11, 7, this one is 5, 7. So the base is just 11 minus 5, which is 6. So if we set the height to be h, we can just plug these numbers into the formula for the area of a triangle. So doing that gives 1/2 times the base, which is 6, times the height, which we're calling h, is equal to 12. And simplifying the left gives 3h, and the right is still 12. And so h is equal to 4. This means that C has to be 4 units above AB. And since AB is on y equals 7, C has to be on y equals 11. So the answer is D. Now, problem 12. Rohan keeps a total of 90 guppies in 4 fish tanks. There is 1 more guppy in the second tank than the first tank, and 2 more in the third tank than the second tank, and 3 more in the fourth tank than the third tank. How many guppies are in the fourth tank? So this is a very clear algebraic problem, and we're being asked for the number of guppies in the fourth tank. So let's set a variable for that, and let's call it x. Now, how many guppies are in the third tank? That would be x minus 3, because there are 3 more guppies in the fourth tank than the third tank. Now we can repeat that for the second and first tanks to get x minus 5 and x minus 6. Now we're also given that there's a total of 90 guppies. So if we add all of these up, it should be equal to 90. When we add them up, we get 4x minus 14. Now solving this equation gives 4x equals 104, so x equals 26. And that gives us an answer of E, and we can keep going. There. Problem 13. Buzz Bunny is hopping up and down a set of stairs one step at a time. In how many ways can Buzz Bunny start on the ground, make a sequence of 6 hops, and end up back on the ground? For example, one sequence of hops is up, up, down, down, up, down. So for this problem, we can first realize that the bunny has to take 3 steps up and 3 steps down. Otherwise, the bunny won't end up in the same place that it started at. So let's start by seeing if we have any other conditions in the problem. Well, obviously the bunny can't go below the staircase. So at any point in time, the number of ups has to be at least the number of downs. So you can never have more downs than ups. So we'll denote ups with U's and downs with D's. So let's start thinking about how we can construct a string of U's and D's that give us a successful pattern for the bunny. So obviously we need to start with U because the bunny can't start by going down. And then after that, the bunny can go up again or it can go down again. Let me actually make this a little more near. And we can go down instead of sideways. So you have to start by going up. And then you can go up or down. Now, if we think about this path, starting with 2 ups, then from there, again, we can go up or down. Now, if we take 3 ups to begin with, then we have to take 3 downs. There's no other option. Now, if we start with up, up, and down, then we can go up or down, just like always. Now, let's think about this point. At this point, we've taken 3 ups and 1 down. So now there's only one option, and that's 2 downs. Now, thinking about this point, we've taken 2 ups and 2 downs. So now we're back at the ground, and we have to go up and then down. Up and then down. All right. So now we can go to the other side of this tree that we have here. So we're starting with up and then down. After that, you have to go up because you'll be back at the ground and you cannot go down again. Now, where have we seen this before? 2 ups and 1 down already. Well, when we were at this point, we had taken 2 ups and 1 down. And we're in the exact same situation, except we took those 2 ups and 1 downs in a different order. But that doesn't change anything. That we can still make the same steps we made in the other case. So the 2 solutions we got here also apply here. So we get 2 solutions here, 2 solutions here, and 1 solution there for a total of 5 solutions. Now, on to the next one. Problem 14. The one-way routes connecting towns A, M, C, X, Y, Z are shown in the figure below and not drawn to scale. The distances in kilometers along each route are marked. Traveling along these routes, what is the shortest distance from A to Z in kilometers? Well, looking at the diagram that we're given, it looks like a mess. So we can't start by just trying things out and going from A to Z. So let's try something a little bit clever. What if the problem instead had asked us, what's the shortest distance from C to Z? Well, that would have been a lot easier. That would just be going along that route. So let's note that down. If we started at C, then the shortest path would be 10. Oh, whoops. So if we started at C, the shortest path would be 10. Now, what about Y? Well, from Y, you can either go directly to Z or you can go to C. So if we went directly to Z, then that path would be 17. So let's note that down, 17. But if we went to C, then that path would be 5, and then we would have to take the shortest path from C to Z. But we already know that that shortest path has a length of 10. So that would be 5 plus 10, and it would be 15, which is shorter than 17. Now, let's think the same thing. Now, let's think in the same way about town M. So if you're at M, you can either go directly to Z with a path of 25, or you can go to Y, which is 6, and then you can take the shortest path from Y to Z, which we found to be 15. So 6 plus 15 is 21. Or you can take a path of 14 to C, and then take the shortest path from C to Z, which we found to be 10. And that would give a total of 14 plus 10, which is 24. And obviously, the smallest number in this list is 21. So let's replace that list with 21. Now, we'll just continue what we're doing. If we're at X, the shortest path from X to Z, well, from X, you can either go to Y or to M. So if we go to M, that's a path of length 2, and then the shortest path from M to Z has a length of 21. But if we go from X to Y, then it's a path of length 10 plus a path of length 15, and that would be 25. And obviously 23 is the smaller one. So the shortest path from X to Z is 23. Now, finally, we'll answer the question, what's the shortest distance from A to Z? So from A, you can either go to X or you can go to M. Now, if you go to M, that's 8 plus a path of 21, which has length 29. If you go to X, that's a path of length 5 plus a path of length 23, which gives you a shorter path of length 28. So that was actually a clever recursive solution to find a large value using smaller values, because we started at the shorter path from C to Z and then Y, and then we stretched it out to M, then X, then A. Now, let's keep going. On to question 15. Let the letters F, L, Y, B, U, G represent distinct digits. Suppose FLY is the greatest number that satisfies the equation 8 times fly equals bug. What is the value of fly plus bug? Well, we notice that on both sides of the equation, we have 3 digits that repeat themselves. So we see a similar form on both sides of the equations. And when we see something similar on both sides, we try to cancel it. So what happens if we have something like ABC? What can we say about it? Well, it seems like we can factor out the number ABC. And what are we left with? Well, 1000 would give ABC 000. So what do we need to get from there to here? Well, we need to add 1. So that means that this number was ABC times 1001. So now that we have that observation, let's go back to the actual question. So on the left side, we have 8 times fly, which we now know is fly times 1001. And on the right, we have bug, which we know is bug times 1001. Now we can cancel 1001 from both sides. And we now have 8 times fly is equal to bug. And now we're stuck. So when we're stuck, let's think about how we can use our answer choices. And let's also think about what we're actually looking for. We're not looking for fly or bug. We're looking for their sum. So let's think about what their sum would come out to be. So fly plus bug, that's just fly plus 8 times fly. And factoring out fly shows that this is equal to 9 times fly. So we have to find the value of 9 times fly. But the key that we have to remember is in the problem, it asks for distinct digits. So F, L, Y, B, U, and G all have to be different. So let's test fly times 9 for each of the answer choices given, and we'll figure out which one outputs a result where all of those digits are different. So the first choice was 1089. So let's create a table. So the first answer choice is 1089. Well, the answer, since we know it's 9 times fly, we can just divide this by 9 to find that fly is equal to 121. But in this case, F and Y are the same, so this is not possible. Our next answer choice is 1098. option B. And dividing that by 9 gives 122. And now L and Y are the same, so that won't work either. And the next answer choice is 1107. And in this case, fly turns out to be 123. And multiplying that by 8, because bug is 8 times fly, gives bug to be 984. And here we see that all the digits are distinct. And now we know that the answer is just C. That's all for this video. Thank you for watching. Don't forget to hit that like and subscribe button. And we'll see you next time here at Mathlete's Corner.